In problem number 100, we want to estimate the height. To estimate the height of a building, a stone is dropped from the top of the building into a pool of water at ground level. How high is the building if the splash is seen 5.6 seconds after the stone is dropped? So again, we're working with the position function. S of t is equal to negative 4.9 t squared plus v sub 0 t plus s sub 0. And this is the model of free fall for objects falling or shooting directly up, vertically up into the air and then coming back down again. So we want to estimate the height of the building. Now what do we know? We know that the object is dropped from the top of the building, and since it's dropped, it wasn't thrown down, it was dropped. That means that the initial velocity is 0, and because of that our function has become a lot simpler. Since v sub 0 is now 0, all we have left is negative 4.9 t squared plus s sub 0. And s sub 0 is what we're trying to s sub 0 is the height at time t equals 0, is what we're trying to find out here. Well, something else that we do know is that at time t equals 5.6 seconds, the height of the object is 0. It hits the ground. So that tells us that if we plug in t equals 5.6 into the function s of t, so we'll get negative 4.9 times 5.6 to the second power plus the initial position has to equal 0. And so all we're going to do now is solve for s sub 0, and we do that by moving the negative 4.9 times 5.6 to the second to the other side of the equation. Sorry, it's going to turn out to be positive there, and as it should, because the height of the building is positive. And so we just need our calculator to multiply this out, and we get 4.9 times 5.6 close parentheses to the second power, and that tells us that the height of the building is roughly 153.6 meters tall, or 0.7 meters tall if we round. So that tells us that the height of the building that we dropped the ball, sorry, that's not 157, it's 153.7, which tells us the height, and I'll close down the calculator. It tells us that the height of the building would have to be 153.7 meters in that case. And so this is a simple introduction to vertical motion here. It seems like with the second one we didn't even need to have a derivative there. But we'll stop this video here and go on to the next problems in the next video.